Hi, welcome to Wafu TV. It's a new day and we have a new lesson for you. Today we'll be looking at index notation as we promised in our last lesson. But before we go into index notation, we want to first of all do a quick review of our past lesson. And this is what we have. How to express a number as a product of its prime factors. How do we do this? Express 36 as a product of its prime factors. We are going to use two methods side by side, and you will choose one which best suits you. Follow up, because it is from the result of this that we are going to get into index notation. How do we express 36 as a product of its prime factors? We will break it down using prime numbers. The first prime number we have is 2. So 2 times which number will give us 36? 2 times 18. We go down again. This 2 comes down. 18. How do we break 18? Using prime numbers. We take 2 and 2 times which number will give us 18? 2 times 9. We are going to break it further. 2 times 2 times 9. How do we break 9 down using prime numbers? 2 cannot break it down. So we go to the next prime number, which is 3. So 3 times dash will give us 9. 3 times 3. So 3 times 3 gives us 9. 2 times 2 times 3 times 3 will give us 36. 2 times 2, 4. 4 times 3, 12. And 12 times 3 is 36. How can we write this in another format? Instead of writing it like this, we can decide to write it as 2 square times 3 square. Take note of this answer. Let's look at the second method on how to find the same 36 or express 36 as a product of its prime factors. We write 36 and use our prime factorization table. So we start with the smallest prime number, which is 2. 36 divided by 2 is 18. We can take 2 again. 18 divided by 2 is 9. Here we cannot use 2 because 2 cannot divide 9. So we take the next prime number, which is 3. 9 divided by 3 is 3. The next is 3. 3 divided by 3 is 1. And at this level, we end because we have arrived at 1. So we are going to express 36 using these prime numbers. That is 2 times 2 times 3 times 3, which is the same as 2 square times 3 square. If you look at the two methods, the answers are the same, which means if you use this or that, your answer will be the same. But look at something. The answer, the final answer, 2 square times 3 square. This is what we call index notation, and that introduces us to the topic of today, index notation. Before we go into finding out what index notation is, let us state our objectives as usual, what we want to learn at the end. First of all, we want to be able to write numbers in index form. If we have numbers in extended form, we should be able to write it in index form or contracted form. The next objective is to be able to expand numbers. Numbers which are written in index form, we should be able to expand it and write in expanded form. And lastly, for today, we should be able to add, subtract, multiply, and divide numbers which are written in index notation form. With this in mind, we should be focused on attaining these objectives at the end of our lesson. What then is an index notation or power? Look at this expression, 5 raised to the power 3, or 5 cubed, or 5 to the third power. This is how you can read this in 3 different ways. Okay, this can equally be written as 5 times 5 times 5. And This way, on the left hand side is the index form or contracted form, and on the right hand side is the expanded form. So this is a short definition of what index is all about. An index or power tells the number of times a number is multiplied. Look at here, we have 3, and this small 3 written here is the index or the power. It indicates that 5 is multiplied 3 times. That is what this definition is talking about. For better understanding, let us have some examples. Example 1 says, solve 2 square plus 3 cube. How do we do this? Follow up carefully so that you can understand the steps. First, you expand on the left hand side and on the right hand side. 2 square plus 3 cube will be the same as 2 times 2. 2 square means 2 times 2, plus 3 cube means 3 times 3 times 3. 2 times 2 will give 4, plus 3 times 3 9, and 9 times 3 is 27. And if you add 4 plus 27, the answer will be 31. That's just it, as simple as that. Let's look at the second example. Example 2, 4 to the power 5 times 2 to the power 4. We expand same as we did in the first example. That is 4 times 4 times 4 times 4 times 4, all in brackets, times, open another bracket, 2 times 2 times 2 times 2. 4 times 4 is 16. 16 times 4 is 64. 64 times 4 will give us 256. And 256 times 4 will give 1024. You bring this multiplication down. 2 times 2 is 4. 4 times 2 is 8. And 8 times 2 is 16. If you multiply 1024 by 16, you're going to have 16,384. That is the second example and how we can expand to have the answer. The next example, example 3, says 8 square minus 2 cube. We expand. This is equal to 8 square, 8 times 8 bracket minus 2 times 2 times 2. That is 2 cube. 8 times 8 is 64 minus 2 times 2, 4. 4 times 2, 8. 64 minus 8 will give 56. If you have a problem that you are supposed to subtract or multiply or add, the first thing is expand each side and then add or multiply or subtract. Let's look at the last example. Example 4 says 5 cube divided by 5 square. Let's expand. 5 cube is 5 times 5 times 5. Bracket open and closed, divided by 5, bracket open, times 5, bracket close. 5 times 5 is 25. 25 times 5 is 125. Divided by 5 times 5 is 25. So 125 divided by 25 will give 5. That is that we had for you today as far as index notation is concerned. With this, you should be able to add, subtract, multiply, or divide in numbers written in index form. If this is your first time watching us, subscribe to our channel, like, share, and comment for better services. See you in our next lesson. And on our next lesson, we'll be talking about mixed problems. Ciao.